2 days, we've been talking about parallelograms. We're going to continue our parallelogram discussion. But now we're going to get specific into our type of parallelogram. So our parallelograms have those 5 qualities. Opposite sides are parallel. Remember, that is the definition of parallelogram. Opposite sides are parallel is our definition. And then we have some properties. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary, which means they share a side. And then the diagonals bisect each other. When we talk about a rectangle has all of those qualities because a rectangle is in fact a parallelogram. So a rectangle has all 5 of those qualities, but it also has some that are just for it. So the first one is, in a rectangle, all 4 angles are right angles. The 4 angles that are created, the 4 vertices are all 90 degrees. And then our diagonals in a rectangle, the diagonals are congruent. So the full length of the diagonal is congruent. So when you put that together with the whole thing, the diagonals bisect each other, we know that it creates 4 congruent sections. All right, let's take a peek at number 3. Yeah, so we can dole out some punishment. That's awesome. So let's go ahead and find some of our angle measures. So first off, what do we know is true about the angles in a rectangle? They're all 90. So every single one of our vertices is 90 degrees. So by giving us 27, they gave us everything. So we know all 4 angles are 90. They gave us 27. What other angles would be 27? What you got, brother? What other angle will be 27? Yep. Right? So alternate interior angles exist. So what would the measure of this angle be? How come? Alternate interior angles are always congruent. Now, you ready for another flashback? No. What did we say about the diagonals? They're all what? They're all congruent. So all 4 of these pieces are congruent. That is very nice of them. You know what's even nicer of them? What kind of triangle is this light blue triangle? It's isosceles. And what do we know about the base angles of an isosceles triangle? They are congruent. So if the base angle is 27, what would the other angle be? 27. So what would the angle down there in the bottom left be? NML. 27. So we've gotten a bunch without even doing any math yet. Now we got to do a little bit of math. Hooray! So angle J measures out to be what? 90. Angle J is 90. So that means this angle, let's call it theta. Wow. Theta and 27 are complementary. What's it mean to be complementary? Hey, their sum equals 90. You are. So theta plus 27 equals 90. Subtract 27 from both sides. Yes, sir. So that angle is 63. Isn't that all I did was subtract it? But didn't I just subtract it? Okay. I did. 90 minus 27. Oh. So what other angles are 63? All of the other ones that are outside. What about those interior angles? Can we find those? How? They are, we can find mu by just doing the triangle sum theorem. So like she said, mu plus 63 plus 63 equals 180. 63 and 63 is, survey says, 126. And then we subtract 126 from both. What does it measure to be? Mu is 54. So this guy would be 54, which means the angle that's across from it is also 54. What about those other two in there? I could do that. I could do that. 100%. So we could just say, hey, that thing right there, that's a linear pair. So 180 minus 54 is 126. Wait, where did we see that number at? Didn't we see that number already? And the light blue, it's almost as if it's an exterior angle. And that is just the sum of the two remote interior angles. We're done. There's nothing else we can do. We're done? So look, 54 is an exterior angle for this triangle, which means if I add those two together, that's what it equals. And then what about this one? 126 is an exterior angle for this triangle. If I add those two together, 126. All of our rules just come flying back. All right, MJK. What's the measure of MJK? Almost. Almost. Follow the vertices. MJK. 90.
That's 90 degrees.
Thank you. MJL. Hey. JLK. 63. KML. 27. And MNL. 126. You guys are rock stars. Let's throw some algebra in there now. Because we like algebra. That's Elizabeth's bottle. So find the measure of EF. These are all rectangles. Remember, rectangles have the properties of a parallelogram. So opposite sides are congruent. So CD is congruent to FE. And if our sides are congruent, then they are equal. So we can set these equal to one another. So 3x plus 5 equals 7x minus 39. And we just got our linear algebraic expression. Solving for x, we're going to subtract 3x from both sides. So 5 equals 4x minus 39. My next step would be to add 39 to both sides. Because ultimately, what are we trying to do? Isolate that variable. Get it by itself. 5 and 39 is 44. Isn't it nice when they just come out nice, pretty numbers? X isn't quite all by itself yet. We've got to divide both sides by 4. So 11 equals X. Is that what it wanted? What did it want? EF. So I could also plug it into CD. How come? They are congruent. Y'all want to plug it into EF or CD? Let's do both just in case. So 3 times 11 plus 5. 3 times 11 is 33. 33 and 5 is 38. 7 times 11 is 77. 77 minus 39 is 38. It is congruent. We did something right. We do have we have both actually. Yeah, number 7 says RT is 5x minus 14. That's the full length here. 5x minus 14. And US is 2x plus 10. Well, it's a rectangle, so what do we know about the diagonals in a rectangle? They're congruent. And if they're congruent, that means we can set them equal to each other. So we subtract 2x from both sides. (3x minus 14).
No, I'm writing in highlighter.
Can't write in highlighter. I only call myself dummy. I wouldn't call somebody else a dummy.
It's an accurate description.
I will call you a weirdo. 3x equals 24. Divide both sides by 3. So x equals 8. But it wants the measure of VT. So we're going to find the full length of RT and divide it by 2 because that rascal was bisected. So RT is 5x minus 14. Is that right? Did I translate it right? Yeah. Substitute 8 for x. 5 times 8 is 40. And then 40 minus 14 is 26. But that's the full length of our diagonal. And remember, because it's a parallelogram, our diagonals are bisected. So we just take 26 and divide it by 2. So our answer is 13. All day. Whoa. No. Wow.
On fire.
Wow. Number 8. JM is x plus 17. And MK is 5x minus 23. So what did they give us individual diagonal pieces for?
Oh, you're gonna put them equal to that, and you're gonna
Why are they equal to each other though?
because the midpoint.
All of our diagonals in a rectangle are congruent. Fine. So remember, all 4 of these pieces are going to be congruent. Because our full diagonal is congruent, thanks to our rectangle property, and then off the rectangle property, our parallelograms say, hey, those diagonals bisected each other. So it cuts it into 4 congruent pieces. You okay? All right. So we can just set them equal to one another. And then solve for x. Add 23. 17 and 23 give me a number. 40. It is a number.
Yeah.
And then divide both sides by 4. So x equals
I know, right?
10. But is that what they wanted me to solve for?
No, they want you to solve for J.
They want us to solve for JL.
So you plug it in.
So we can plug it into JM.
And then
So if we substitute it in for JM, which was x plus 17. So 10 plus 17 equals 27. But that's only half of our diagonal. To find the full length, we're going to multiply 27 by 2, which is 54. All right, let's look at number 12. Last one we're doing. Number 12. Oh, that's probably just alternate interior angles, so they're equal, right? Yeah, let's find out. Oh, no. They're not alternate interior angles.
But you can like add them to, you can, if you add them together to get 90, because every single rectangle has a 90 degree. Yeah.
So let's stay on that alternate interior angle thought, though. If I were to do alternate interior angles here, right? If I were to do alternate interior angles, what would the measure of that angle be? What would the measure of WXZ be? What would the measure of WXZ be?
X plus 5x minus 8.
Nope.
I don't know.
Nope. It'd be X plus 20. Because what do we know about alternate interior angles? They're congruent. So I can just rewrite that up there. And now we can go on what you were talking about, Chica. So that's a 90-degree angle, correct? So those two angles are complementary, which means their sum equals 90. So x plus 20 plus 5x minus 8 equals 90. You did. Thank you. Sure. So we're going to combine like terms. So we get 6x plus 12 equals 90. Wait, is that right?
Wait, no.
No, what's wrong?
Oh, never mind.
Are we sure?
Yes.
20 minus 8?
Yes.
Subtract 12 from both sides. So 6x equals 78. Divide both by 6. And x equals, bump. He did waddle away. X equals,
I don't care.
13. And it wants us to find xzw. So xzw, we could really say is 5x minus 8. Yes? Alternate interior angles again. Does that work? X, Z, W. Are those alternate interior angles? Yep, so I can legally do that. It is legal. So the measure of X, Z, W equals 5x minus 8. Substitute the value of x we just found, which was 13. 5 times 13 is 65. Great answer. Thank you, ma'am. And 65 minus 8 is 57.